Hello everyone, welcome to yourfaculty.com. We're going to deal with more problems on volume and surface area in this video. This is our website yourfaculty.com and this is our Facebook page. So we'll start with the first question. A cistern 6 meter long and 4 meter wide contains water up to a depth of 1 meter 25 centimeter. So they are all in meter. This one alone is in 1 meter 25 centimeter. The total area of the wet surface is, first step, let's convert this 1 meter 25 centimeter into meter. It's 1.25 meter. 1 meter is equal to 100 centimeter, right? So this is 1.25 meter. So let's just assume this is cistern. Okay, I'll take off the three-dimensional piece here, or maybe I'll draw that. And water is up to a certain level, right? So what are they saying? They are asking for total wet area. If you imagine a cistern or a cuboid, or assume you're seeing a box, and if you're pouring water in it, which are the regions it is touching? It will touch the bottom, it will touch all the four sides and the bottom, right? But water doesn't touch the top. The top, because water still not reached that region, and we don't know whether the cistern is closed or open, whatever it is. So at least in this case, it is very clear that water is not touching the top. So it's just they are just asking for the total wet surface, which is basically your four sides of the cistern and the bottom. So please kindly visualize it. So what happens is you are this region, you are this region, you are this region, except for the top, all the other regions are all wet. So let's first write the surface area formula. Surface area of a cuboid is equal to 2 into LB plus BH plus HL, right? In this case, the top portion alone is not wet. So what happens? That's your length and breadth. So what happens here? The wet region is equal to 2 into LB plus BH plus HL minus LB. So what are we left with now? We are left with, if you can subtract and all that, you will have LB plus 2 into BH plus HL. So what is LB now? Length is equal to 6 and breadth is equal to 4. 24. 6 4s are 24. 2 into BH. We know B is equal to 4, H is equal to 1.25 and length is equal to 6. So 4 into 1.25, 5 plus HL, 1.25 into 6, it's 5 plus 2.5, 7.5. So we have 24 plus this gives you 12.5. 12.5 into 2 is 25. So your answer is 49 meter square because the area. Next question. A boat having a length of 3 meter and breadth of 2 meter is floating on a lake. The boat sinks by 1 centimeter when a man gets onto it. So when a man gets onto it, the boat sinks by 1 centimeter. The mass of man is, see, there is a key concept that you need to understand here, that the question that is being asked is not volume but mass of man. Okay, so I'll get on to that important point when we arrive at mass of the man. First, let's find out what is the volume displaced. Volume displaced because of man is equal to what? Is equal to the boat sinks by 1 centimeter. So equal to the level at which boat went down, right? Which is what? 3 into 2 into, this is meter, this is meter, this is centimeter. So 0.01. So when a man jumped into the boat or got into the boat, the volume that it displaced, or a volume that it went down, the amount of the level at which it went down is 1 centimeter, because of which there's a change in volume, right? So the volume of water displaced because of the push of boat downwards is this, which is what? 6 into 0.01 is 0.6 meter cube. So now, how do we find out the mass of the man? To calculate the mass, we should first know density of water. So density of water is equal to 1000 kilogram per meter cube. So we need to know that with this density of water and the volume, we will be able to arrive at the mass of man. So mass is equal to volume into density. See, volume is in 0.06 meter cube and density is in 1000 kilogram per meter cube. This gets cancelled and you have 60 kilogram, which is the weight of the man. So the key here is to know that density of water is 1000 kilogram per meter cube, and the question that is being asked is mass of the man and not the volume of water displaced when man enters the boat. So when the volume of water displaced when man enters the boat can be easily calculated by this, because we'll assume that this is looking like a cuboid. So 3 into 2 into the height, which is 0.01, so 0.06 meter cube, and mass is equal to volume into density. Thanks for watching our video. You can subscribe to more videos at your faculty channel. Like us on our Facebook page and our LinkedIn page, and you can also follow us on Twitter. Thank you.